Yes, it's there, sir.
Okay. Okay, so let's start. So hi there, my name is Ajmi. So I'm a researcher at ICFOS, working in LoRaWAN and LoRaWAN applications for sustainable development. So first, let me speak about ICFOS and a little brief introduction about my work here. So ICFOS is International Center for Free and Open Source Software. So it is an autonomous organization set up by the government of Kerala, which have the combined mandate to popularizing free and open source software for universal use. So ICFOS carries out a number of FOSS-related activities in a model that brings together the academia, the government, the FOSS community, and the FOSS community. So these are some of the activities of the ICFOS. So it includes research and development, support to FOSS software development, FOSS pilot programs, local language computing, study on FOSS, exploring FOSS certification, exploring technology alternatives. We work on technology, assistive technology, and all that. Capacity building of students to enter the FOSS community. So ICFOS also has a incubator for the startups. So currently it also started a pre-incubation facility this year onwards for young entrepreneurs. So now let's jump. And I will discuss our work at our Open IoT lab at the end. So let's start with connecting things or IoT. So what is IoT? What is connecting things? So by definition, if we see, the Internet of Things is a system of interrelated computers, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and ability to transfer data over a network without requiring human to human or human to computer interaction. So this definition is a bit confusing, right? So let us see a simplified explanation. So currently we are currently we are having this session online. So that means is some of us are joined. Some of us are joined through computer. Some of us are log in through through laptops. Some of us are using mobiles, tablets. So all of this is connected to internet, right? So connecting things to internet gives us amazing benefits. So we have seen these benefits when we are using our phones, televisions, computers, and but these things can be true for other things also. So other things also, like connecting everything and day-to-day things to internet. So the Internet of Things means taking all the things in the world and connecting them to the internet. So let us understand the benefits of connecting things to the internet, and why does it matter. So point one. So when something is connected to internet, it can receive or send or receive information, or it can do both. So this ability to send and receive information is making a device smart, right? And we know smarter is better. So we are using smart TVs, and we are moving into smart cities and all that. For example, let's say in our smartphone, you can now listen to any song in the world right now. So is it because that song is stored in your phone? No, most probably you're streaming from any streaming services like Spotify or Ghana or something. So you are you are basically sending a request to a cloud service where that song may be stored in some other computers, or some computer, say a cloud storage, and we stream the song. So, and all this is happening because of internet. So mm, so overall, we have three categories in IoT. So first is sensor that collects the information and sends it. Second one is computer that receives the data and act upon it. And third one is the systems which do both the operations. Let's see collecting. Let's see one by one. So collecting and sending information. So sensors. So sensors. What are sensors? So sensors are small devices, so which can measure temperature, motion, air quality, uh, and almost anything now in today's world. So these sensors, when gets connected to the internet, allows us to collect information about our environment, about our surroundings, which we with which we can make better decisions in our day-to-day life. So suppose, for example, there is a suppose there is a soil moisture device installed in a farm. So, and suppose a farmer gets the data, gets the soil moisture data, and instead of watering too much or too little over a period of time, he can actually on basis of that soil moisture data, he can actually crop the he can actually water the crops exactly the right amount of water. So that is actually collecting and sending information. So the sensors are collecting it, we are acting upon that information. Second one is receiving and acting on information. So the machines that receives the data. So this particular thing is not new. So basically, machines are always working upon a given instruction, like a printer. It prints a page when we are given the instruction. A gate can wirelessly be controlled to open and close. So it is basically when the signal is sent, it does the operation. So it is indeed very common thing. So the power comes uh, when these things can act upon the information received from some sensors or from some other devices. So suppose you are in a car and you are about to reach your home, and your car tells your front gate about your arrival, and the gate opens. So interesting, right? So it is object talking to each other. And the third one is sending information and acting upon receiving. So suppose the farmer who installed the sensor to monitor the soil moisture, upon getting the information, he was watering the land as needed. So with a proper IoT systems enabled, uh, he didn't need to switch the irrigation system on or off. So basically, he only need basically the irrigation system can act automatically as needed based on the moisture level and moisture level that sensor got. So, and suppose the irrigation system is connected to internet also, and and when it receives the information on weather that it is going to rain, so actually the system can decide whether decide not to water the crops at as the rain will water the crops as they water the crops they need. So, and processing the information, it doesn't stop there. So all this information about soil moisture and how much irrigation system is watering the crops, and how well the crops are growing, can be collected and sent to a supercomputer in cloud that runs algorithms that can analyze all the information leading to model uh, that could be used to predict the future conditions and to prevent losses. So this is a basic example. So suppose it is not only one sensor. Suppose there are other sensors, light sensors, air quality, temperature, humidity, and all these sensors, the data from all these sensors can be sent to some algorithms which can learn more, which can learn much more, and with dozens and thousands of farms collect from all farms. When we are collecting all these data, so we get a very incredible insights into how to make crops grow the best, and which will help feed the world's growing population. So after this, so now let us try to define IoT. So what is IoT? What are connected things? So the Internet of Things, or IoT, as we say, these about extending the power of internet connectivity beyond computers to a whole range of other things, processes, and environments. So those connected smarter things can be used to gather information, send information, or it can do both. And why does it matter? And why does it matter? So IoT provides businesses and peoples better insight into control over objects and environments that are currently beyond the reach of internet. So by doing so, IoT helps these people to be connected to the world around them and do more meaningful and higher level of work. So 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 this is basically IoT. So now so these are some of the examples. So basically, reading data from the environment, we can use in the medical field, we can use in the transportation, in agriculture sector. uh, so so let us now see the components in the IoT system. So as we talked about, so there are sensors which collects the data. There is a connectivity part. So this connectivity part is very important. So after the data is collected, so we have to decide by which medium the data gets transmitted to the server or to the cloud, or how the device is communicating to each other. Then comes the data processing. So data processing is basically when the data reaches a server, it has to be converted into meaningful, uh, it has to be given meaning, uh, upon which we can take actions or actions accordingly. So then is the user interface. So user interface is basically a feedback system to the user, whether to actuate or to visualize all the happenings. So let's talk about the connectivity part. So as we are learning about the LoRaWAN thing, so we will be concentrating on the connectivity part of the IoT ecosystem. So let us. So connectivity is a critical piece of this IoT puzzle. So in most businesses or the big stakeholders, they need to find the most suitable connectivity option for the products and projects. So with several IoT options on the market today, so the constant evolution, their constant evolution and development of the new ones. So there are constant evolution and development of new ones. So uh, which means in order to identify a specific and special or and the one connecting technology, it is not going to be easy. So so new technologies like LPWAN and 5G are gaining more attention, while others, Bluetooth and Wi-Fi, they are evolving and they are changing themselves to to get more suitable to the IoT landscape. So broadly, we can divide this connectivity into short range and long range. So I'm not talking about the medium range. So short range and long range. So here we can see a basic thing: the cellular and the LoRa spectrum, the Wi-Fi, Bluetooth. So the Wi-Fi, Bluetooth, they all comes in the short range thing, but high bandwidth side. And the cellular basically comes in the medium to high range covering category. So talking about short range applications, short range connectivity options. So we have Wi-Fi and Bluetooth. These are classic connectivity solutions. So the capacity of these classic connectivity protocols are naturally limited to the expectations of the past days when IoT was just just cropped up around the home automation projects, so smart home projects and all those small basic things when the starting of the IoT. So now these short range solutions are being modified and adapted to a new reality created by an avalanche of data from connected devices. So talking about Wi-Fi, let's see what are the positive points of Wi-Fi. So Wi-Fi is perfect for data intensive uses and in building or campus environments like home automation, energy, house energy management, and all those kind of use cases. So in most use cases, Wi-Fi is 20 to 30 times quicker than Bluetooth low energy, making it a more suitable choice when the trans when we need when we need to transmit large files. And what are the minus points? So as we are transmitting large files, naturally the power consumption is very high. So, and Wi-Fi is initially not designed expressly for the IoT networks. There are recent developments of standards which are looking more into the IoT capabilities. So, what is the takeaway? So these sensors, the key elements in IoT developments, they are basically battery operated and battery based and transmit small amounts of data over huge distances. So they need some other kind of connectivity solutions. And talking about Bluetooth, so Bluetooth has Bluetooth is very much perfect for some applications like personal IoT devices. So wearables, fitness trackers, as well as beacons. So Bluetooth has been very popular in the consumer electronics segments for its ability to continuously stream large amounts of data. And BLE was specifically designed for low-powered IoT devices. So BLE is best suited for devices that transmit low volumes of data in bursts. So as well as devices are designed to save power when they are not transmitting data. So Bluetooth device is basically designed as a low power device, and it can continuously stream large amounts of data. And the third positive point is it is very low cost device. So, and talking about the downsides, so its application in industry projects has been very limited because of its very short range connectivity. So, and it has a very, even though it is designed to save power, the consumption is relatively very high. The battery consumption is very high. So still the low price of this solution attracts developers who have introduced these hybrid architecture schemes with Bluetooth. So which help to overcome the Bluetooth short range restriction. So these schemes use Bluetooth for connecting dozens of end devices to one master access device. So in turn, that master device is connected to some other technology like cellular for connecting it to the backend. So connected to the backend. So next. So as we saw, this Wi-Fi and Bluetooth have its advantages and disadvantages both. So both can be used. Both can be used as a bridging device actually. So in order to we can connect dozens of devices to one master device using these technologies, and we have to use some other device to connect it to an internet or to some backend device. And talking about then comes LoRaWAN, LPWAN, sorry. So LPWAN is a currently it is a perfect solution for massive IoT projects like smart cities or smart agriculture. So what are the plus points? So let's see. Plus points: low power wide area network. It is an umbrella term. So LPWAN is an umbrella term for any network that allows communication over larger distances. So mostly it is at least 500 meters of signal range from gateway to the end device, and using minimal power. So these networks can be divided into licensed and unlicensed, licensed and unlicensed, that we are going to we'll be seeing later on this. So and these solutions have designed particularly for IoT. So therefore, they are designed to send small amounts of data at uh, longer intervals from a lot of endpoints. So, but within a long period and at longer distances. And what is the weak point in here? So basically, LPWAN they are all in early stages of development. So its full potential and disadvantages won't become very much clear until the networks have been implemented at a greater scale, at very large scales. Then comes 5G. 5G is a perfect solution where we need most bandwidth intensive applications like remote surgery, massive machine type communications. 5G networks are next generation of mobile internet connectivity. It offers faster speeds and more reliable connections on smartphones and other devices than ever before. So again, the minus points are time will be needed to make 5G universal. Plus, we need to see wait and see whether the reality will correspond to the higher expectations. So next, let us try to understand the LPWAN technology. So LPWAN basically stands for low power wide area networks. So the exponential growth of Internet of Things and machine to machine communication in last few years has been had been an impact has had been an impact on almost every aspect in our daily lives. So it is expected that by 2025 more than 75 billion IoT devices will be connected and working around the world. But how are these IoT devices going to be connected to the internet? So generally speaking, IoT and M2M applications and devices have low power and low data transmission requirements. So the data is usually coming from a sensor, uh, and it is very um, it is very little amount of data. So until recently, the technologies used for connecting these applications and devices were not ideal ones for IoT applications. For example, wireless personal area networks, and Bluetooth, that were designed primarily for medium to high speed data communication in short range environments, as we discussed earlier. So wireless cellular networks, 2G, 3G, 4G, 5G, they were designed for high speed data communication in medium range environments. So these networks are usually employed in voice, data, and video communication. So as we are doing today. So in order to meet the particular requirement of IoT and M2M application and devices, something had to evolve to meet this particular requirement of IoT and M2M application and devices. So this is where comes the LPWAN technology. So LPWAN emerged. So LPWAN emerged in the 2013 So this is a generic term which describes a group of network technologies designed to communicate small data packets on low transmission data rates wirelessly over relatively long distances using lower power than common network technologies. Okay, so transmission of small packets of data, low power consumption, wide signal coverage. So these are the ideal characteristics of a IoT application. So small packets of data, low power consumption, and wide signal coverage. So this is the basic. This is a basic characteristics of an IoT device and application. So here we can see the bandwidth and range distribution of different technologies. So talking about types of LPWAN technology. So in recent years, there are two main categories that have emerged. First one is non-cellular based networks, and second one is cellular based networks. So these types of technologies can use licensed or unlicensed frequencies and can use proprietary or open standards. So let's talk about major and most widely deployed LPWANs today. So that would be Sigfox, LoRaWAN, NB-IoT, and LTE. So, non-cellular based technologies. So what are non-cellular based technologies? So non-cellular based technologies are basically they are operating under the ISM bands. First one is Sigfox. So Sigfox is most widely utilized LPWANs today. So it is a proprietary ultra narrowband LPWAN technology which runs over a network in the 868 or 900 megahertz frequency bands. So these frequency bands, as I said earlier, it is a ISM frequency band. So basically they are free to operate. These frequencies are free to operate and does not need any license to operate. So this network can deliver messages over distance of 30 to 50 kilometers in rural areas and over 3 to 10 kilometers in urban areas, and up to 1,000 kilometer in line of sight application. So in a normal packet size, when we are sending these is 150 messages of 12 bytes per day, with a downlink packet limited to four messages or 8 bytes per day. So then talking about LoRa, so LoRa is a physical layer technology that works in the unlicensed ISM frequency band. Okay, it is based on the chirp spectrum technique. So LoRa is basically a single hop technology which relays the messages received from a sensor from a LoRa sensor node to a central server via gateways. So the data transmission rate supported by LoRa varies from 300 bits per second to 50 kilobits per second. To support LoRa over the internet, the LoRa Alliance has developed LoRaWAN, so which includes network and upper layer functionalities. So we'll talk about LoRaWAN next. So LoRaWAN basically provides three types of class operations depending upon the use. So let's talk about LTM now. So in cellular-based technologies, we have LTM and NB-IoT. So LTM actually starts for long-term evolution for machines, and NB-IoT is narrowband Internet of Things. So both are wireless telecommunications technologies, which is developed by the 3GPP developed by the 3GPP group. So unlike Sigfox and LoRaWAN, um, so these LTE and NB-IoT are operated by wireless network providers and this network providers. So LTE is compatible with the LTM is compatible with the existing LTE networks. So it provides extended coverage comparable to LTE networks, coverage for M2M applications similar to 5G networks, and offers a seamless path towards 5G M2M solution. So LTM is focused on providing variable data rates and support for both real-time and non-real-time applications. It supports low latency application as well as deferred traffic applications that can operate within latencies in the range of seconds. So it has low power requirements and supports operating range from low bandwidth to a bandwidth as high as 1 Mbps. So LTM also supports devices with a very wide range of message sizes. So NB-IoT can coexist with the GSM and LTE in the licensed frequency bands of 700, 800, and 900 megahertz. So it is basically using the existing GSM infrastructure. So NB-IoT is designed by optimizing and reducing functionalities of LTE so that it is used for infrequent data transmission with low power requirements. So the data rate supported by NB-IoT is 200 kilobits per second for downlink and 24 uplink. So the maximum payload size can be 1600 bytes. So for each message. So talking about LP1 technologies, so let's talk about the applications. So we can see here the plus points, the limitations, and the applications. So the plus points of the LoRaWAN, as we see, so it is long range, low power, and low cost. The limitations are it is the very limitation is very low data rate and high latency. And the applications. So LPWAN are commonly used in smart metering, smart lighting, asset monitoring and tracking, smart cities, precision agriculture, livestock monitoring, energy management, industrial IoT deployments everywhere. So choosing an LPWAN depends on the specific applications, namely the desired speed, the data amounts, and the area covered, the real-time application of the real-time factor of that application. So when we are and we have to choose a technology depending upon the application. So LPWAN are best suited for applications requiring very infrequent uplink message. So maybe periodically, once in 1 hour, once in 2 hours, and smaller and delivery of smaller messages. So most LPWAN and technologies can also have downlink capabilities with lower power requirements, longer range, and lower cost than traditional mobile networks. LPWANs can enable a number of M2M IoT applications which are previously constrained by very budget and power issues. So, some of the LP1 technology, some of the applications are smart garbage meters, smart parking meters, weather monitoring, asset tracking, and all that. So let's understand LoRa and LoRaWAN first. So LoRaWAN is so let's understand the difference first. So LoRa is basically a wireless modulation technique. So it is derived from chirp spectrum technology. It encodes information on radio waves using chirp pulses. It is similar to the way dolphins and bats communicate to each other. LoRa modulated transmission is a robust against the disturbances and noises, and can be received across greater distances. So LoRa is ideal for application that transmit small chunks of data with very low bit rates. Data can be transmitted at longer range compared to other technologies like Wi-Fi, Bluetooth, or Zigbee. These features make um, LoRa well suited for sensors and actuators that operate in a very low power mode. So LoRa can be operated on license-free sub-gigahertz bands. So, for example, in India, we operate on 865 to 867. So there are other bands like 915 megahertz, 433 megahertz, and currently works are going on in the 2.4 gigahertz to achieve higher data rates compared to the sub-gigahertz bands at low costs. So these frequencies, all these frequencies, as we discussed earlier, all these frequencies comes under the ISM bands. So basically, it is a license-free. It's a license-free band. So then comes the LoRaWAN. So LoRaWAN is a MAC layer protocol, media access layer protocol. So and it is built on top of LoRa modulation. It is a software layer which defines how devices use the LoRa hardware for example, when they transmit and format the messages. So the LoRaWAN protocol, it is developed and maintained by the LoRa Alliance, and the specification, all the LoRaWAN specifications uh, can be found in the LoRa Alliance website. So why is LoRaWAN so? What are the applications of LoRaWAN? So why is LoRaWAN very awesome? And so let us try to understand some aspects of LoRaWAN. So first, it is a low power, ultra low power. So LoRaWAN and devices are optimized to operate in very low power mode, and a single device can operate up to 10 years on a single coin cell battery. So there are devices which proves this ultra low power capabilities. So long range. So LoRaWAN gateways can transmit and receive signals 10 um, over 10 kilometers in rural areas and up to 3 kilometers in 3 to 5 kilometers in dense urban areas. Deep indoor penetrations. So LoRaWAN networks can provide a very deep indoor coverage, as easily they can easily cover the multi-floor buildings. License free spectrum, so you don't have to pay any expensive frequency spectrum license fees to deploy a LoRaWAN network. So in fact, everyone, anyone who have a little knowledge and who can browse the internet can set up a gateway, set up a LoRaWAN gateway and work around it. Geolocation. So LoRaWAN network can determine the location of end devices using the triangulation without needing a GPS. A LoRa end device can be located if there are at least 3 gateways that can pick up its signal. So high capacity. A LoRaWAN network server can handle millions of messages from thousands of gateways. Public and public and private deployments. So as I said earlier, anyone can deploy a gateway anywhere. So it is, since it is license free, and we can deploy it in the public, or we can use it for the private LoRa networks, and both use the same hardware, so we don't need to change any there is no hardware specifications. So and end-to-end security. So all the messages, all the communication between LoRa and device and the application server, all are 128-bit encrypted. Updates, firmware updates over the air. So you can remotely update the firmware for a single end device or a group of end devices. Okay, the devices can be programmed remotely. So low cost, minimal architecture, minimal infrastructure, low cost end nodes, and since it is open source software, so we can see many versions by the many developers. So LoRaWAN also supports roaming. So we can use so LoRaWAN end devices can perform seamless handovers from one network to another. So LoRa Alliance is providing some certification programs to certify these devices, which ensures the reliability and compliant to the LoRaWAN specification. And the ecosystem. So LoRaWAN has a very large ecosystem of device makers, gateway makers, antenna makers, and network service providers and application developers. So this is why LoRaWAN is very useful and awesome. So next, talking about the use cases. So these are some of the use cases which are provided by the Semtech company. So they are one of the founding members of the LoRa Alliance. So to give you so LoRaWAN can be applied into vaccine cold chain monitoring, so animal conservation, smart farms, water conservation, cattle health. So LoRa in space, there are satellites to provide LoRaWAN based coverage worldwide. So now let's see the architecture of LoRaWAN. So what we have to understand. So as I said earlier, so LoRaWAN is a media access control protocol for wide area networks. So it is designed to allow low power devices to communicate with internet connected applications over long range wireless connections. So LoRaWAN can be mapped to second and third layer of OSI model. So it is implemented on top of LoRa or FSK modulation in ISM radio bands. So LoRaWAN LoRaWAN protocols are defined by the LoRa Alliance and formalized in LoRaWAN specification, which can be downloaded in the LoRa Alliance website. So so these are the end devices. These are the end devices, means the sensors we talked about earlier. So these talk to the gateways. These talk to the gateways over the LoRa networks. So these gateways are connected to the network server through a internet backhaul. So it can be 3G, it can be Ethernet, it can be 4G. And these mostly the network server and application server are in the same space, but we can give a different space to the application server. So let us see one by one. So what are the functionalities of each one? So end devices are which are nearby gateways. End devices basically are the devices which are in the near premises of the gateway, and each gateway is connected to a network server. So LoRaWAN networks use an Aloha based protocol. So the end device don't need to peer with specific gateways. So messages sent from one device can travel through all the gateways within range. So if there are two gateways, the two gateways, both the gateways will get the same messages, like we can see here. Okay, and the messages will be the deduplication. That messages will be handled by the network server. So let us understand one by one what are end devices, gateways, network server, and application. So end devices, a LoRaWAN end device can be a sensor, an actuator, or both. So they are often battery operated. These end devices are wirelessly connected to the LoRaWAN network through to the LoRaWAN network through gateways. using the RF modulation. So gateways and nodes are communicating each other with using a LoRa RF modulation. So gateways are these are specific. These are some of the end nodes. These are some of the end nodes which can collect data and send collect data from sensor and send it to a LoRaWAN network. So there are then comes the gateways, which each gateway is registered to a LoRaWAN network. A gateway receives LoRa messages from end devices, and it simply forwards them to the LoRa network server. So gateways are connected to the internet through IP backhaul. So these IP and traffic from gateway to the network server, it can be backhauled through any internet technology like 3G, 4G, Wi-Fi, Ethernet, anything. So there are two types of gateways: indoor and outdoor. So we can mainly categorize into indoor gateways, outdoor gateways. So indoor gateways, they provide coverage in difficult to reach indoor applications, and therefore very suitable for home application, in building applications, businesses and all. Outdoor gateways are suitable for providing coverage in rural, urban and dense urban areas. Um, this type of gateway is intended to deploy for deployment in places like cell towers, the rooftop of very tall buildings, etc. Usually, the receiver sensitivity of outdoor gateway is much higher than the receiver sensitivity of indoor gateway. So, as we can see, so this is a basic outdoor gateway. So, this is a basic indoor gateway. Then comes the network server. So the network server basically manages the LoRaWAN network. So it receives IP packets from gateways. The network server has some network management functions. So like over-the-air activation. So activating over-the-air activation is activating activating device which joins the application in the network server. Message deduplication, so eliminating duplicate messages which are received by multiple gateways. So message routing, uh, message routing, so forwarding uplink message payloads to appropriate application servers, and forwarding downlink messages coming from the application server to the end devices, and forwarding join request and join accept messages between devices and the join server. So all these functions are done by the network server. Adaptive data control, data rate control. So data rate is basically increasing the spreading factor or the data rate of the message, depending upon the range, and distance of gateway and node. Then acknowledgement of messages, so providing acknowledgement of confirmed data messages, and some MAC commands. So all these are functions of the network server. So then comes the application server. So application server basically process the application specific data messages received from end devices. So it also generates all the application layer downlink payloads, and it sends them. So the application layer, it generates application layer downlink payloads which has to be sent to the end device through the network. Network. So the collected data can be interpreted by applying techniques like machine learning, artificial intelligence to solve business problems or to make the data meaningful. Then comes join server. So join server is so basically the join server processes the join request of the end devices. So it stores root keys, it generates session keys. It transfers those session keys to the network server and application server. And now talking about LoRaWAN. So basically LoRaWAN devices and devices. So so we have basically three types of devices, device classes. So basically these device classes are the how the device these are the device operations, basically how the device should operate. So so the LoRaWAN devices, it must implement class A device. So whereas class B and class C are the extensions of specification of class A. What are class A devices? So class A devices, it supports bidirectional communication between device and a gateway. Uplink message can be sent at any time. So the device then opens two receiving windows, RX1 delay and RX delay after that uplink transmission. So as we can see here in the picture. So the device, so if the server does not respond to either of the receiving windows, the next opportunity will be after next uplink of the message. So so basically class A device, a class A N device, they are battery operated. They have a very lowest energy consumption. They spend most of the time in sleep mode, and usually keeps very long intervals between uplinks. So these are periodically monitoring devices. So we can send that it can send data in an interval of 15 minutes, in interval of 1 hour, and whatever the application demands. And generally class A device have very high downlink latency. So since to receive a downlink, the device must send an uplink. And some of the common use cases are environment monitoring, animal tracking, fire detection, water leakage, location tracking, etc. Then comes class B devices. So class B devices extend, and these are the extension of class A devices, by adding scheduled receive windows for downlink messages from the server. So using time synced beacons transmitted by the gateway, the device periodically opens receive windows. The time between beacons, it is known as the beacon. It is known as the beacon period, and the time during which the device is available to receive downlinks is a ping slot. So class B device also open receive windows after sending an uplink. So class B devices have low latency when compared to the class A N device. So because they are reachable at pre-configured times and do not need to send uplink to receive a downlink, the battery life is shorter in class B than class A. So some common applications can be smart metering and temperature reporting, etc. So this is a ping slot, and this is basically a class A operation, after which a beacon is sent and a ping slot is opened. Then comes class C devices. So class C is also an extension of class A by keeping the received signal, receive windows open unless they are transmitting, as shown in the figure. So this allows for low latency communication, but in many times more energy consumption than the class A devices. So since it is always listening mode, since it is always in listening mode, the class C devices consume the most battery power. So, but mostly these class C devices are mains powered. So, and it have no downlink latency, since and since there is a continuous receive window. So these are the some. This is the summary. Let's talk about end device activation. So these are some of the important terms. So there are two types of activations basically in the network before sending and receiving messages. So this is known as every end device will register itself to the network. So that process is activation. So there are two activation methods. So over the air activation and activation by personalization. So over the air activation is recommended. It is the recommended activation. So device perform. Sorry. So during the join process, in an over-the-air activation process, the device address and the security keys are negotiated with the network by the device. By the device activation by personalization. So in activation by personalization, so it requires hard coding the device address as well as the security keys in the device. So so naturally the activation by personalization becomes less secure than OTA. And it cannot switch networks when in ABP. So when we talk about all the
me, sir.
Yeah.
Can you please give the example of last one, activation by personalization?
We'll be doing the doing the practical demo. So so you will understand basically both processes. So we'll be only doing activation by personalization, but you will also understand what is OTA. So basically it is, so we are encoding keys, security keys, and device address. So a device address, a network session key, and application session key. So these are the keys which we will be providing, which will be hard coding into the device. So when we are programming the device, these keys will be provided in the device, as well as we will be registering with that keys in the network. So I hope you understand. We'll be seeing that in a demo also. Okay. Then comes the the security, the limitations. So LoRaWAN is, as we saw here, LoRaWAN is not suitable for every use case. So it is important that we understand the limitations. So LoRaWAN is only suitable for long range, a low power and low cost, which the device which can operate in a low bandwidth, a device which can operate in a low bandwidth in a low bandwidth data rate. So so naturally it cannot be used for real-time data. So it can, since it can only send packets every couple of minutes or in a regular interval, we cannot make any phone calls. We cannot control lights. For that we have Zigbee and Bluetooth technology. We cannot send photos or watch Netflix over LoRaWAN. So for that we have Wi-Fi and all other technologies. So we must clearly understand the use cases when we are when we are trying to use LoRaWAN. So these are some of the devices we at IC Force are developing and we are working on. So some of our development includes AWS, automatic weather stations, water monitoring solutions, parking solutions, energy metering, air quality, and our lab is equipped with a small scale prototyping system. So other than LoRaWAN, OpenIoT Lab is actively working in drone technology and GIS. So I guess this is it. So these are some of the here we can see a gateway. So this is a outdoor gateway at Trivandrum district. So this is basically a LoRaWAN based AWS, and this is a project. Basically, we provided uh, we provided the network coverage across Kerala. Uh, Network coverage across Kerala to spread the word about LoRaWAN as much as possible, and we are building ecosystems based on working with all these organizations. So that's all the lecture part. So let me. So now we have a virtual lab. So let me share that first. So virtual lab. So what is a virtual lab? So when we have a faculty development program, okay, I think it's visible. So virtual lab is basically a basically a computer. Let's see. It is basically a computer. Um, so uh, a Raspberry Pi and a Arduino board connected to a server, which can be accessed through your system through a web browser uh, using the virtuallab.icpost.org URL. So what we are doing is uh, uh, we are accessing the Raspberry Pi in the user interface in the all the with all the with the complete UI system, and in with that we are programming a LoRaWAN based board, which can be LoRaWAN based board. Okay, so when you are using a virtual lab, you don't need to install anything in your computer. You just need a web browser to access it and to learn and study learn and study the technology. So this is basic. This is how the interface looks, and okay, I think we can start with this. This is the lab you're going to work. So okay, so this is about virtual lab. So I think I'll show some demo here. So let me see. I think you can see. So when you will go to virtuallab.icforce.org, so you will be asked with a login and a username. So I think you are all shared with the login and username with the groups created. So if you have any doubt, you can ask here. So okay. So
I think we have not provided with the link.
Ajmi, I think I have shared a document on your WhatsApp group. The
Okay.
first line itself is that link map. So I think we will ask people to log in first, Ajmi.
No, for first, let me. So can I
You
show?
demonstrate it, and then people
First,
we will ask people to
okay.
log in. So you just say which side to go. Can you start
Okay.
from there itself? That
Okay.
beginning thing.
So I'll be showing you a demo. I'll be printing using a basic. So this is like a basic computer. So anyone who uses a computer or who has programmed before will not find any difficulty using it. So, but let me. So this is the.
Site എന്തൊരു പെട്ടി വന്നായിരുന്നു ഒരു വ്യൂ എന്തൊരു കുഴപ്പമില്ല.
So this is so this screen you will be you will see when you enter the lab. So this is the Arduino IDE. So I hope you all are familiar with Arduino now. And you have to wait. You have to be a little bit patient. Sometimes it can be a little slow, and especially when three of participants are using single system. So so let me just try to.
Ajmi,
Sir.
I think people. You can ask people to log in. Maybe so we will move further before after asking people to log in. Maybe that is the most difficult part, I think. Right.
Okay. Okay.
So we can ask people to log in to using that ID to their system. Let everybody log in, and then we will maybe continue. We will go very slow. So let people log in. I think I have given everyone that login name and password. So they can go to that virtual labs at icforce.in, give the username and password, and then log in. Then they will get the screen. So shall we move like that, or you will do a complete demo?
No.
We have logged in, sir.
You have logged in. Anybody having issues with logging in? So they can ask it now.
Yes, sir, my network is slow, sir. Kindly give
Yeah.
some time.
So it will log in. Anybody having issues with logging in, please mention that in the comment box. So we will try to help out.
And you can also talk with your fellow teammates in the group.
Okay, I think then I think this is everybody if everybody has logged in, I think you can move ahead. So you can monitor there, no? How many people have logged in?
Yeah. No, not like. Let me just inform my team actually.
Yeah. Your team can monitor.
Yeah. So I was hoping that if anybody needs to see this, if I think everybody is familiar with Arduino from yesterday's class. Yeah.
Sir, I have one query, sir.
Yeah. Okay.
Sir, I have one query.
Yeah, Puneet, go ahead.
Sir, actually, I have a Raspberry Pi in hardware with me, but I have not the gateway kind of thing with me. Can I do the experiment without any gateway?
No,
with only
not
Raspberry
actually.
Pi and Arduino?
No, actually, it needs with Raspberry Pi you can do it, but it needs a you have to have a concentrator, LoRa concentrator to build a gateway. So this is actually a what are you? So I think you're asking about the virtual lab, right?
No, sir. In virtual lab, I am doing all things that you are explaining. I am asking about how to realize that thing because I have already Raspberry Pi hardware with me.
Okay. So the thing is, the boards which are connected here, they are connected to we have gateways established here. So these gateways are talking to a things network server. Okay. So about that things network, I'll be showing you what is things network. I'll be giving you a demo on that. And uh, so in that Raspberry Pi, you can do your programming and all stuff, but I'm sorry, you cannot send the LoRa packets there. You can program it, yeah, definitely you can program it, but you cannot without a gateway, the data won't be sent to the network.
Okay, sir. Okay, sir. Thank you.
Lab 7 logged in. Okay. Anybody having a problem logging in?
Sir, I have logged in. It is showing lab 4.
Lab 4. Okay. Okay.
And
Sir,
inside there is a
lab
folder
one.
workshop documentation.
Yes. Yes. So
This is lab 1.
lab 1. Okay. I think we can start. So let me let me tell you what we are going to do today. So give me 5 minutes. I'll talk to my team first. Yeah. Sir, Sunil sir, is that okay?
Ajmi, is it okay now? So he's gone?
He went to talk with his teammates. Sir.
Oh, it's okay.
It's okay. That's okay.
I said people are logging in.
Yeah, people are logging. So I'll be telling what we are going to do, the process. So
Yeah.
then we'll begin. So I need to talk with my team. So I need just 2 minutes.
Oh, sure. Yeah, I didn't. So I was also on phone, and then I didn't see you. That's why I told. Okay, fine. I think Ajmi, we can go on a very slow pace. We have 6 sessions, and see if people are having issues, they let them ask. So
Okay.
so we will be sitting here unmuted. If anyone of you are having an issue, just raise it here. Okay. Okay, you can continue, please.
Yeah. Okay, sir. Just 2 minutes, sir. Okay, I think you all got the group link also, and you can talk to your team. So first, so apart of so before going to before moving forward to the um, what to say the LoRaWAN part. So we will first do a hello world in the serial and a hello world and reading a sensor. So if you open that workshop document, okay. So there is a folder in the there is a folder in folder in the desktop, right? So you can see a manual there. So
I think, can you project one screen to everyone?
sorry, sir.
Can you project one screen?
Oh, yeah.
Your manual or what?
Yeah. So okay.
Okay. Are you sharing this document to everyone? It is on there on the system, no?
Yeah, it is on the system. It is on the system in the folder.
Okay. Oh, so okay. So that is what you are telling.
Yeah.
Because we are clueless. We are sitting here and we don't know what was happening. So that's why I asked. Sorry.
Okay. So I think everybody is on board, right? So.
All right. You can continue, please.
Okay. So I'm assuming everybody is familiar with the Arduino, and you know what is digital write, what is digital read, what is delay, what is serial print. So is there anybody
Ajmi, one more second. I have actually completed up to this point.
Okay.
In the morning, but only thing is that it was in a virtual environment. You can just show that IDE. I have no IDE also.
Yeah. Okay.
That you can show because I taught all the up to this virtual serial thing in a virtual environment.
Okay.
Yesterday we learned.
Okay. So let us learn the hello world thing. So first program is this, the hello world. So since this is a virtual environment, and so we cannot see the LED, right? So it is the hardware is kept at our premises. So we'll first see a serial print the hello world. So I'm accessing lab 6. So whoever is using lab 6, so please be patient. So you can see your desktop movie. Actually, use lab 6, right? So I'll share my. So you can see, right? Okay. So this is the basic Arduino IDE. So let's start with serial. So this is basically what we are doing. We are initializing serial with the 9600 baud rate. Okay, and now what we have to do is print anything. Print ln. Hello. Okay, and we'll give a small okay, you are asked to save that sketch. So I'll go to documents. I will say hello everybody. Save it. Okay, it starts compiling, starts uploading, and yeah, done. So then we'll see the serial monitor here. Okay, and it shows hello everybody. Okay, I think this is clear. So can you do it? Can you try it? So just leave a comment if someone is having problem.
Yes, sir. Wait, sir.
Okay, so I'll give you a new sketch. Close it. And okay, lab 6 can use it. Please refer to the manual if you have any problems. So,
Sir, could you share this manual to us?
um, the manual is in the so you want it in your mail or
Yes, yes, sir. Yes, mail or WhatsApp.
So Ajmi, if Shafiq or somebody can share to the WhatsApp group.
yeah
that.
yeah okay.
So I think that will people will have they can download and
yeah
then
okay
see.
okay.
Excuse me, sir. Hello,
Yes,
sir.
yes, yeah.
Sir, I'm in lab 4.
Yeah, okay, okay.
So here, after typing the codes, at the end, I was supposed to put the semicolon, but somehow I'm clicking, but it is not responding. Whether connection.
Yeah. Okay. No, it's not about the connection. It will be done. Actually, the save dialog, the window, it went into the back. It
Okay.
went to the back side. Okay.
So this is the saving option, right?
Wait. Okay. So if I think everybody is done. Yeah? If you have anyone is lagging behind, please just say. Lab 4, your issue is solved now.
I am unable to type left 4.
Just wait.
I am seeing the screen, but I can't.
Okay. You're talking to your team members, or
In the WhatsApp group, no one has talked. I am starting to talk.
okay.
Excuse me,
make
sir.
Yeah.
This is from lab 1.
Okay.
It's I think it's very slow. It's showing saving operation alone.
Saving.
I typed I can't able to see the serial monitor. It's
1 minute.
yeah.
It is solved now.
Yeah, yes, sir. Thank you so much.
Yeah. Okay.
Okay. What I did wrong? It's anything wrong over there?
No, it's not. It is actually when you are saving it, the folder goes to the backyard.
Okay.
Okay. The previous serial monitor was already there.
Okay. Fine. Okay. Sir. Thank you.
Sir, kindly check that I have compiled and run.
Are you able to see the message which you printed? It's running, right?
Yes, sir, it is showing.
Yeah. Just mention your lab number when you are asking the doubts. Mention your lab number. Our team members will guide you through. Okay. I think everybody is doing. A workshop manual. So the workshop manual is shared in your WhatsApp group. You can refer that.
Hello, sir.
Hello.
This is lab 4. I have given a 1 second delay and thereafter it is printing with a delay.
Lab 4.
Yes, sir. It is printing with a delay. That is, I have provided one delay of 1000 milliseconds.
Okay.
Yes, sir. Next, what we have to do?
Next, I want to know if all the members have done it.
So other members are not responding. I have written some message.
Okay. So then try on the day one program for reading. So there is a so let me show you. So next, so next there is BME connectivity. I'll give you 5. I'll give. So if anybody wants to do it, just carry on with it. I'll explain it after 5 or 10 minutes.
So this is item number 24. What we are doing?
I didn't understand what is item.
There is slide number 24.
We did the slide number 24. Hello world.
Okay, sir. Okay. Yes.
And in hello world, please also type that in the serial mode. So when you are typing the void setup and void loop, void setup runs only once. Okay, as you might have learned yesterday. And void loop is the continuous loop. So if you want to see the sometimes when you are using the serial print in setup, that hello world may not get printed when you open the serial print. So it might have the time when you the serial window is when you open the serial window, the print might have gone. So just type that serial print in the loop, so you can see that if anyone is having a problem.
So next, what we have to do?
Next is go down the slide to slide number 28 and read BME 180. So this BME 180 is connected to a I2C port of the things you know. So that is basically the A4 and A5 pin. And this BME 180, it gives temperature and pressure, barometric pressure. So the codes are given in the folder. If you don't want to see that code, you can actually refer to internet and try it.
Sir, in which folder?
In the desktop. You can see it in the desktop actually.
Okay.
In the desktop, workshop documents, day 1.
Programs in program.
In programs, day 1. Yeah.
Day. Sir, which sensor it is?
It is BME 180.
BME 180 for temperature and humidity.
And pressure, atmospheric pressure.
Okay. Atmospheric pressure means?
Atmospheric pressure means the what to say, the air pressure actually.
That humidity and temperature sensor is different from this.
Yes, humidity and temperature sensor is different. Actually, we had planned that one, but we didn't have the sufficient amount to plug it into all the virtual labs. So that we use BME. For that we use DHT11. So this is actually a barometric pressure in which barometric sensor, so in which we'll get the temperature also. It is basically we are interfering a I2C device to I2C device to a to the controller, to the board.
Sir, it is it is using Adafruit cloud, I think.
Yeah, it uses Adafruit libraries.
Using Adafruit client.
Yeah, Adafruit libraries. Yeah. So that library is a what is it? That is a unified sensor library actually. So it not only covers this but different types of sensors. So it for workshops like this, so it's kind of easier to understand.
Yes, sir, getting output, pressure and temperature, and altitude.
Okay.
Hello, sir.
Hello.
Actually, I just wanted to ask that it's showing the temperature, pressure, and altitude. So, from where it is showing means like
yeah,
which place?
that's yeah. It is which place means. So this sensor is attached to the controller here at our premises. So naturally, it is showing the temperature, pressure, and the altitude data of our lab.
Okay, sir. Sir?
Yes.
Sir, are you there? Yeah. Hello.
Hello.
Yes, sir. Sir, is my voice audible?
Yes, yes.
Sir?
Hello. Yeah, please go ahead.
Yes, sir. Sir, actually, I was asking like we are seeing the temperature, pressure, whatever the sensor is collecting the data of your place. So it is going through the IoT connectivity. Like from our end, we are the receiver, and there it is this sensor collected the data to your end, and then it's like server. Through server, we are getting the information from our end. So whatever.
No. Actually, what is so it is just what we are doing now is basically just sensing that temperature. So we are not sending it to anywhere, right? So you are seeing that in the virtual environment only, right? So in the serial monitor itself, right? You understand what I said?
A little bit.
So you can see the temperature data in the serial monitor only, right? So you cannot take that data and visualize it somewhere, right? So are you able to do that?
No, sir. Oh, yes, sir. I got it from virtual lab. It's like, yes, I got it.
Yeah. So so what we are going to do, most probably tomorrow, we will learn about the LoRaWAN application server and the network server, and we will try to send this same data to a web interface. Okay, there you can have this data. So from the data which we are collecting from our lab, you can have that visualize in your application, any application.
Okay, sir.
Okay.
So this is lab 9. This only one text file is available in day 1.
Just copy that text file and paste it in the copy the content in the text file, copy the programs and paste it in the IDE, Arduino IDE.
ID. Okay. Okay. Thank you.
Anybody have any doubts, or anybody want to try something new? How many of you are familiar with this Arduino IDE or anything related to programming? Team 7.
Ajmi, how is it moving? People are doing?
Yeah, people are doing. So,
so what should be our next plan? Like,
so my plan was to move into LoRaWAN tomorrow, but let us see if we can give some other programs they can do.
So in the next session, what to do?
Next session, if everybody is available, we can continue with LoRaWAN, or anyone who has not done it can.
No, we can continue. Otherwise, I think we can run a session at, say, 6:30, 6:45 or so. We can do it for 2 hours or so.
Okay.
If somebody has an issue, say we can take it up separately. Like we can. So otherwise, I think our schedule will lag. Like we need to have some number of sessions or some basic sessions for the ACT purpose also. So I think any idea how many people logged in? Because we have no clue. Because all the 10 labs are running, no?
Yeah, all 10 are running.
All 10 are running. So shall we continue for some more time, or close it now and restart at 6:30? So what is the idea?
I don't have any problems there. Yeah.
You don't have any problem.
Yeah, if they're doing so, let them do. Or
okay. The problem is that I am going back home, and then I will rejoin from home at 6:30.
Okay.
Sir, we have done BME 180, and thereafter anything we have to do now?
So not as planned, but I was planning to planning for the LoRaWAN LoRaWAN network server network server walkthrough tomorrow. So, but I think we can, if everybody joins, we can do it on the 6th.
Yeah, we can do it in the evening, Ajmi. Otherwise, the entire thing will not be in schedule.
Yeah. Okay.
Sir,
Then
sir, we can do it now for 1 hour, in 1 hour.
Is it possible? I don't know. See, you
And
okay?
evening you can leave.
Yeah. Is it okay with you, Ajmi? Like,
yeah, it's fine.
then we can see how many people will. Some ladies have messaged me that they are unable to do like that. So till what time you guys will be there?
5:30.
Okay, 5:30.
Yeah.
So shall we continue till 5:30 then? This one.
Yes, if everybody is there, then we can continue. I want to know if everybody is comfortable with these, with the environment. So then only we can move into LoRaWAN.
Sorry to interrupt, sir.
Yeah.
Yeah, I have to leave at 4 o'clock.
Yeah, that is issue. Yeah, traveling is there. For many people that issue is there.
I
So
can
actually, I think
connect after 6:30 as per schedule. I can connect at 6:30.
6:30. Okay.
Yeah.
So actually, one thing we can do. So see, if somebody wants to leave, let them leave, and we will. You can continue at 6:30.
Okay.
Is it okay? Then
yeah, it's fine. So
fine.
the lab will be open. So anybody who wants to do or try, so they can do it, and we'll take the next session. We'll move on to the LoRaWAN session in at 6:30.
Yeah.
Sir, for this session, is there any attendance link?
Yeah, I think I heard. Okay, wait. I will post it here. Attendance link I am posting. Just copy it here. Attendance link is to everyone. Yeah, thank you for reminding me. Otherwise, yeah, I think around 31 people are here. You can mark attendance on the form. So I will post it to the WhatsApp group also. So, okay. Let's go to paste. So you can post it. Now the thing is that I am exiting. So I also have to travel to Trivandrum and rejoin it. So I will rejoin back at 6:30.
Sir, the form is not working.
Pardon? With this form is not working? What is
Form
happening?
is not accepting the
Oh,
response.
wait. I will. Okay, I heard. Okay, thank you for reminding that.
So the form is not accepting response.
Wait. Now it will accept. Is it okay? Yeah. I have turned on acceptance. You can mark. Thank you. So Ajmi, I am making you a co-host. Huh?
Yeah. Okay.
I am making host now, and I am exiting.
So okay.
I am exiting. I am going home. I will rejoin at 6:30. So we will restart the next session at 6:30. So those who are sitting here, they can work on until as long as there is, some people will be there to support you also. Here. Okay. Thank you. So the 6:30 session will be counted as a separate session. As for the AICT thing, that session numbers and all, I have to post to AMCT. To be frank, I'll tell you that.